So you'll get a copy of this recording.
Okay.
Not maybe this evening because it takes my computer all night to process them, but tomorrow morning.
Okay.
And I will send you a link to whatever email address you put. Is Leah V. Phillips, is that you?
No.
That's the email that whoever signed up the session used.
Oh, that's my mother's account.
Okay, what's your email address?
Phillips, PhILLIPS
What's the after the Phillips?
EC.
EC, okay.
At s.dcsdk12.org.
At s.dcsdk sdk.org. Okay.
12.org, sorry.
I'm sorry, what?
12.org.
12.org. Okay, here, just a second. I'll get this right. And then in the morning I will send to your email a link for you to see the file if you're interested in reviewing it.
Okay.
Now, with trig, you can probably verbally express the problems that you'd like to look at. And I can write it on my drawing tablet, and then we can go to work solving it.
Okay.
Okay. So, what kind of trig are you in the middle of right now?
We just started problems like evaluate the following cosecant 45 degrees using the unit circle.
Okay. Let's draw the unit circle here. Hold on 1 minute. So you've covered all 4 quadrants in the unit circle. You're familiar with what I mean when I say a reference angle?
No. What's a reference angle?
Well, if I'm in the first quadrant, your 3 common ones are 30, 45, and 60.
Oh, okay, yeah, I understand.
Okay, but if I wanted to draw a 150-degree angle, like that takes me into the second quadrant, the way I figure out all the trig functions of that is by looking at the reference triangle. The reference triangle being whatever the triangle is made with the x-axis. Okay, and that theta will give you the same absolute value for the trig function that angle would be if it was in the first quadrant. And in this case, if that's 150, theta is 30. Okay, so first of all, let's talk about a couple of things. Let's stay in the first quadrant for a minute. I was just trying to figure out what you've had and what you haven't. The 2 fundamental triangles that are key in trig, I'm sure you're familiar with these. (45-45) right triangle and the 30-60 right triangle. Now I put what I call these the unit special right triangle, because the side opposite the smallest angle is always 1. But if you want to calculate trig functions, then these 2 triangles will tell you all of your common first quadrant answers. Okay? You're familiar with SOHCAHTOA? I wonder how they taught these before somebody came up with SOHCAHTOA, because every single trig student gets SOHCAHTOA now. So first of all, cosecant is reciprocal to which one? Sine or cosine?
Cosine?
No, I'll tell you how you can remember. We have sine, cosine, and tangent are what I call the three primary ones, even though there's nothing more primary than anything else. Cosecant is the reciprocal to sine. The one you know always is cotangent, right?
Mm-hmm.
Well, so you have to figure out, does cosecant go with sine or does secant go with sine? And the way you can tell is there's an SC in both of those starting letters.
Mm-hmm.
If you were to put secant with sine, it would be SS. So make sure that you put cosecant with the function where it's going to have not the same starting letter. And same with secant goes with cosine. Okay? So if sine is 1 over cosecant, then cosecant must be 1 over sine. So let's figure out the sine of 45 degrees. From my right triangle, what's the sine of 45 degrees based on SOHCAHTOA?
It's opposite of a hypotenuse, so 1 over 2.
1 over, we're in the bottom triangle?
Oh, whoops.
1 over square root of 2.
1 over square root of 2, yeah.
Okay, so that would be the sine. So I'm going to replace sine with 1 over square root of 2. And then if I flip and multiply, that gives me square root of 2 as an answer. Notice that I didn't worry about rationalizing that number, 1 over square root of 2, when I got it, because I'm going to flip it. And as soon as I flip it, that irrational denominator will be in the numerator. So it would have been self-defeating for me to rationalize that before I'm done. You never want to give that as an answer to anything. But if that's just an intermediate step, you can leave it like that. That's the same number as square root of 2 over 2. You know what I mean by rationalizing it?
Yeah.
Okay. So that's the cosecant of 45 degrees is root 2. What else you got? I'm going to leave up everything on there for the moment. Do you have any that are not in the first quadrant?
Yeah, but they're just ones like it says, so it's 10 negative pi over 6, and then on the unit circle I have to find where the negative pi over 6 is, and then plug that into cotangent equals cosine theta over sine theta.
Okay. So your angle is negative 10 pi over 6?
Yeah, just negative pi over 6.
Oh, just negative pi over 6, okay.
Mm-hmm.
Erase the 10 that I wrote in there. All right, positive angles are measured from the x-axis going counterclockwise. Negative angles are clockwise. So what is this angle in degrees? Not that you have to do it that way. You can leave it in radians and think in radians. But most people that are just learning trig, that's a pretty tall task to think in radians. So it almost makes more sense to convert that to degrees.
Would it be negative 30 degrees?
Yeah, let me help you here for a moment. It's really important to realize the following. Pi over 6 is 30. Pi over 4 is 45. and pi over 3 is 60. Notice that that number times that number is 180. Same with that, same with that. So if you always remember that, it's really easy to make the adjustment. I know that there's the formal adjustment factor, but it's actually, this is almost easier. In other words, if I had 2 pi over 3, then it would be 120 degrees, right? So as long as pi is in your numerator, then the degrees times the denominator has to equal 180. So these are useful to remember. All right, so our minus 30 degree angle is that one right there. Now there's two ways to do this problem, and they want to find what? The cotangent of it?
Just the tangent.
The tangent? Okay. There's the hard way and the easy way. The hard way would be to turn that into a positive angle, which would be 330 degrees, and then try to figure out the tangent of 330 degrees, knowing that the reference angle is 30 degrees and the tangent is negative in the fourth quadrant. Have you learned all students take calculus?
Yeah.
And have you learned the reference angle is 180 minus theta in the second quadrant? In the third quadrant, it's theta minus 180. And in the fourth, it's 360 minus theta. So I can see that I'm in the fourth quadrant. So if I wanted to know what the tangent of 330 was, I would use this 360 minus 330. It's going to be the same absolute value as the tangent of 30. I'm going to go over here, I'm going to look at my triangle that's the 30-60. Tangent is opposite over adjacent, so the tangent of 330 degrees would be the same as the tangent of 30, which is 1 over root 3. And now all I have to do is put a plus or minus sign on it. And tangent is negative in the fourth quadrant, so it's that. And since they're asking for an answer, let's rationalize that. How do you rationalize that number?
I'm not sure.
Well, you want to multiply top and bottom by square root of 3. In other words, if I multiply the top by square root of 3 and the bottom by square root of 3, I'm merely multiplying it by the number 1, and it turns it into minus root 3 over 3. And that's a proper answer. Okay? Now, I said there was a hard way and an easy way. Let's go back and look at the easy way. The easy way requires you to know about odd and even functions. And it's worth knowing because it's significantly easier. Okay, here's what the rules are for trig. The sine of minus x equals minus the sine of x because it's an odd function. Same thing with tangent. Tangent of minus x equals minus the tangent of x because it's also odd. But cosine is even. So if I have cosine of a negative angle, it's equal to the cosine of the positive angle because it's even. Okay? So how does this benefit me so much? Well, the problem was, what's the tangent of minus 30 degrees? Well, I know that that's the same thing as minus the tangent of 30 degrees. And now I know that 30 degrees, the tangent of 30 degrees is root 3 over 3, and I put the minus sign in there. So there's no necessity to take this negative angle and go through finding what the positive angle is and then what the first quadrant is and then adding the sine. It's much easier to do it using that property right there. And that property is true for not just sine, tangent, and cosine, but also their reciprocals. In other words, the cosecant of negative x is negative cosecant of x. Okay, let me put a little box around that because I got so much stuff on this page here that it's kind of overrunning. Okay, I don't really want to erase anything on here, so I'll continue to write. Well, I want to erase that because that was the hard way to do that problem. And let me erase some of this, make some room. All right.
So I'm confused. When would I use the formula tangent of theta equals sine of theta over cosine of theta?
Well, yeah, you're talking about the quotient identity.
Mm-hmm.
Tan of theta equals sine over cosine. You could have used that on this problem, but it would have made it harder. In other words, you would have had to figure out the sine of 30 degrees, or negative 30. You'd have had to figure out the cosine of negative 30, and then divide one by the other. You'd have gotten the same answer. But notice how much faster it was to use this triangle and the fact that tangent is opposite over adjacent.
Mm-hmm.
Now, if they absolutely force you to do it this way, well then do it this way. And figure out what the sine of negative 30 is, knowing that that's the same as minus the sine of 30, and then go in and figure out what the cosine of 30 is, and you'll come up with fractions. So you'll have a fraction divided by a fraction, and it'll end up being square root of 3 over 3 with a negative sign in front. It's just that it's easier to do it from these two right triangles, these basic angles like 30, 45, and 60 degrees. The easiest way to do them is to memorize these two triangles over here. And like I said, you've been working with those two triangles back to the days of Algebra 1. You know, all through geometry you had these two triangles, and now in trig they become particularly important. Because the only trig functions they want you to be able to do without a calculator are these kind of angles. They're never going to say to you, what is the tangent of 29 degrees? Because nobody knows that without looking it up in a table or a calculator.
Mm-hmm.
But the common ones, anything that's a multiple of 30, 45, or 60, they do expect you to know without the calculator. And I'm sure you'll get tests where you'll be able to do portions with the calculator and other portions without. What else do you have? Now, did that last problem, it just wanted the tangent of minus 30 degrees, correct?
Mm-hmm.
It didn't really tell you to do it using this method?
No.
Okay. Then you definitely want to use the method that I showed you. You want to start with this, knowing that the tangent of a negative angle is the same thing as minus the tangent of the positive angle, because that gets you there almost immediately. And then just figure out what the tangent of 30 degrees is and put a negative sign in front of it. Okay, what else do you got?
I've got a problem that says evaluate the function without using a calculator, sine 45 degrees.
Okay, it sounds like you're pretty much in the first quadrant. In other words, you don't have any second or third quadrant problems? I mean, the negative angle was a fourth quadrant problem, but not really.
Oh.
Because of this odd property of tangent, it turned into a first quadrant problem.
I have sine 225 degrees.
Those are the ones we should work on. Because anything that's in the first quadrant, you can use these two triangles.
Mm-hmm.
Okay? So let's talk about when we get out of the first quadrant. Those are the harder ones. What was it? Sine of 225?
Yeah.
Based on this, what is the reference angle going to be? In other words, first of all, you need to know you're in the third quadrant. Let's label these quadrants. That's 90, that's 180, and that's 270. So if we're between 180 and 270, we're in the third. And then use theta minus 180. What do you get?
You get 45.
Okay, so I put it in parentheses because the sine of 225 is going to have the same absolute value as the sine of 45. And what's the sine of 45?
Is it?
Looking at this triangle on the bottom.
Oh, okay. Opposite of the hypotenuse, so square root of 2.
Square root of 2 over 2. In other words, 1 over square root of 2 is the same as square root of 2 over 2.
Mm-hmm.
Now is all we have to do, let me write it a little further away, is put a plus or minus sign on that. Well, what is sine in the third quadrant? Is it positive or negative? All students take calculus.
So it's positive, negative?
Negative, exactly. And that's the way I do every single one of those problems, is I do it step by step. In other words, first if I figure out what the absolute value of it is based on its reference angle, which is always a first quadrant angle, then I rationalize it if it has to be rationalized, and then I put the plus or minus sign on it. And that method cannot take you wrong. You can figure out any angle based on that. What's another one you have?
Sine 930.
Sine of 930?
Yeah.
Okay. When we are outside the unit circle, which goes from 0 to 360, we want to bring all of these angles that are bigger than that back into the unit circle. And the way we do that is we subtract as many multiples of 360 as we can. Well, how many multiples of 360 can I take away from the 930? 2. 2, and now it leaves me with an angle that's inside of our unit circle. And that's the key. Okay? So it really is correct to say that the sine of 930 degrees is exactly the same as the sine of 210. So that's step one whenever you're dealing with an angle that's outside the unit circle. Now, again, in parentheses, let's put the reference angle. What's the reference angle for this one?
How would you put it?
Theta minus 180. In other words, every time I ask you the reference angle, you want to use one of these three equations, depending on which quadrant you're in. Well, we're in the third quadrant. So theta is 210. 210 minus 180 gives you 30. Now what's the sine of 30? Looking back over at this triangle.
It's opposite of hypotenuse, so 1 over square root of 2.
No, just 1 over 2. We're looking at this triangle here.
Oh, gotcha.
Okay. And then what's the plus or minus sign on it?
Minus.
If it was tangent, it would be plus. But anything other than tangent or the reciprocal is minus. That's what these letters mean. A means all of them are positive in the first quadrant. Second quadrant, only sine. Third quadrant, only tangent. Fourth quadrant, only cosine. Okay, we've been going for about a half hour here. So this is typically where I would stop, and there's no charge up to this point. If you like this method of tutoring and you want to schedule another session, you're certainly welcome to. I would appreciate payment like by PayPal before the session. My online sessions, if they're an hour, it's $32. If they're a half an hour, it's $16. Same price, basically, half as much. And you can schedule either half-hour sessions or hour sessions.
Okay.
Okay?
Thank you.
You're welcome. And I hope I've been helpful. And like I said, I will... that email address, let me just check after the @ It's dcsdk12.org.
Yep, that's it.
Okay. I will send you the link to this recording, and this is actually a pretty good recording to have because we've covered a lot of really, really important trig stuff here, and this would be a good one for you to review. Because everything we talked about tonight is something you want to memorize. In fact, everything on this page you want to memorize, except for maybe this line up here. But this whole unit circle picture, memorize that. Each of these equations for the particular quadrant and ASTC. All students take calculus. And these reciprocal functions here. All right. Erin, you have a good evening. Hopefully talk to you again.
Thank you.
Bye-bye.